Hello, hello, hello. All right, get these slides up there. Oh, there we go. The title of this presentation is Please Don't Mock Me. That's what my face looked like 7 years ago. My name's Justin. I go by Searls, my last name on most internet things. If you'd like my contact info, you may npm install me. I am the creator and the current maintainer of the world's second most popular JavaScript mocking library, if you don't count Jest or Jasmine. Here's the download chart. That right there is Sign-On, the most popular one, and that's us, Test Double, way down there. This was a big day for us. This is the day we finally caught up, but then npm rebooted all their servers. So we're still fighting. You could totally help goose our numbers by npm installing Test Double today. All of the illustrations that I do will be just using Test Double by happenstance. It's what I know best. I'm here today to convince you that the popularity of a JavaScript mocking library doesn't matter. And you should be saying, well, you're just saying that because your thing's not popular, and you'd be right. But additionally, I'm here because I've been practicing test-driven development with mocks for a decade now, and I really have come to believe that literally nobody knows how to use mocks. And of course, that's a terrible thing to say. I shouldn't say that. I should say figuratively nobody knows. And let's break it down, because there is a group of people who can explain how to best mock things in any given situation, and there's another group of people who always mock things out consistently. Unfortunately for all of us, there's a much larger group of people who use mocking libraries without belonging to either previous group. And so, you know, when we initially wrote TestDouble.js, it was really to like target that intersection of developers who already knew really how to like make the most of their tests. And my goal is not just to become more popular, it's to grow the intersection of people who really understand and get the most out of their mocking library and, as a result, the most out of their tests. So that's what we're here to do today, but to do that, we have to define a few terms first. Whenever I say the word subject, I'm referring to the thing being tested, like an experimental test subject is where it gets that name. Whenever I say dependency, like if you're testing a module, anything that that thing imports or relies upon that is external to it is a dependency. And whenever I say unit test, I'm not using a really like fancy definition or nuanced term. Really, like if you're invoking a function and you assert certain things come out the other end, congratulations, you have a unit test. The catch-all term for all types of mocks is test double, whether you're talking about a stub or a spy or a mock or a fake. But today I'm going to like, you know, disregard all of that and just use mock because it's the most common vernacular. Coincidentally, and sort of unfortunately from like a branding perspective, I'm also from a company called Test Double. We are not a mocking library manufacturer. Instead, we're actually a consultancy. And what we do is we pair up with teams, maybe like yours, who are looking for additional senior developer talent. And we join you on contract to work alongside you, get things done, and hopefully with an eye to like, helping you make things better along the way. You can learn more about us online. This talk has 4 parts. The first part is obvious abuses of mocking. We're going to move on to the less obvious abuses. And then we're going to move right along to the questionable uses that might have some value, but people often mess up. And finally, the one good use for mocking that I found in you know, all this practice. So first, let's start with the obvious uses. And that is using partial mocks. So you've like mocked out part of a thing, but left part of the other stuff real. And to illustrate, let's say that you run a park ticket kiosk machine. You know, people tap on the screen, and then you know, they say, hey, I'm 12 years old. And so we check our inventory module to ensure that the child tickets are available before we try to sell them. If they'd said they were 13, we check for adult tickets. And either way, because we want to like upsell them during the checkout phase, we make sure that we have express passes available to sell. The logic like might be implemented in code like this. You know, if they're under 13, ensure we have a child ticket. Otherwise, ensure we have an adult ticket. If the express module thing is turned on, make sure we have those, and so on and so forth. A test for this, how would that look? Well, we'd create another test module over here, and then we'd invoke the code just like we normally would. But what about this ensure child ticket? Because it's like a void function. It doesn't return anything useful. So like, how would we assert on that? Well, we could mock out that method on the inventory and then return back and verify that that call took place. And a way to do that, we just poke a hole in reality, replace that method. And then for this code path, we just invoke it like normal. And then, you know, Test Double and a lot of mocking libraries come with a way to like verify a particular invocation happened just how you like it. For the other code path, for the adult, we'd write another test case. We'd poke a second hole in reality. While we're there, we can make sure we don't call that one during the child code path. That wouldn't make sense. And then mostly just copy paste and then update the values. We can run this test. Great, test passes, looks good. Fortunately, time marches on, and you didn't do anything, but you get a phone call that the build is broken and your test is the one failing. So you run the test again, and sure enough, it's failing. In two places, we're calling the adult code, the adult inventory ensure adult thing an extra time when we didn't expect to. And that doesn't make any sense to us because we haven't changed this code. We look at it, nothing's different here. So we look at the only thing that's actually external. Still a real method ensure express pass, that's still getting called, so that means we have to go now load up this inventory module, and we can see the maintainer of that module actually added an intrinsic call to ensure adult ticket. Maybe they don't want to sell express passes if they're out of stock. And that might make sense to them, but like, can we really blame them for breaking our tests? Like, were they expecting this zombie, half-real, half-fake inventory module to be floating around somewhere? Probably not. So we don't have really any recourse except to poke a third hole in reality. And we can make the test work, but something feels wrong. It's almost like our ship is sinking and our solution is to poke more holes in it. So in this case, you know, the test felt good initially because it was superficially simple. It was terse and it only said what we cared about. But underlying that was that we didn't really have good experimental control for what we were trying to specify. So instead, what I'd recommend you do, fake out the whole thing. That way, it's really clear what the contract line is, and then require your thing and test it as usual. In short, if you have a dependency and it's a totally real dependency, that's really easy to maintain because we're used to invoking code that's real. If you have code that's like a dependency that you've completely faked out, whether with the tool or not, at least you have total experimental control, so the expectations are clear. But if you have this like dependency that's like half real and half fake, it's going to fail for surprising reasons, and you're going to have a bad time. The second obvious abuse that I see of mocking is people partially mocking out the actual thing, the subject, the thing that they're testing. This advice is short. Please don't fake out part of the things that you're testing. You know, I get pushback sometimes like, oh, well, we have a very, very large module. It's got all these methods, and they call each other, and there's just no other way to get coverage of this little thing right here, so we need to poke holes here and there to get our tests running. The problem with that is like now you have two problems. You have a big thing that nobody understands and tests of it that nobody trusts. So please don't do that. Third obvious thing that we see is when people replace some of the dependencies under test, but not all of them for a given subject. And so to explain, I'd like to use a word over-mocking. If you've heard this term, I think it's kind of like a prevailing ideology of how people think about mocking in tests, as if it's an affordance to be moderated. Like you have this mockometer that's like slowly building up as you mock things. But oh, watch out, because you don't want to over-mock. You've crossed some invisible threshold, so don't do that. And it's a strange way to think about it, so let's talk about it. Let's say that you write a system that handles airplane seat reservations, and you're great, you're pair programming together at work. And so you think about the different dependencies that you need to implement this subject that's under test, and then you talk about the different test cases that you need to implement. And because you're pairing, you try to normalize on approach, and so, you know, person on the right says, hey, I like mocking out my dependencies, and the person on the left, you know, doesn't like mocking, tries to avoid. So, you know, you're pairing, so what do? You compromise and just mock out half the things. That is not a laugh line. That's just how people really do this. So you mock out half the things, and as far as this ideology of mockometers go, you're looking good. You're 46% or whatever. But time passes, and you get another call, because the build is failing, and it's your fault. And so you can see here, you know, request seat, our module is calling this seat map with a particular address, and then it gets the seat object back. And you can see it's like a string, right? Well, the problem is that they've updated that contract, and now they expect it to be a dasherized address. And so our test blew up. Well, the person on the right who prefers to isolate their dependency says, hey, this failure has nothing to do with the subject. And, you know, she'd be right. Like, you see, the seat number is just kind of passed in like a baton. We don't do any of the string manipulation stuff here. And so she changes that real dependency to a fake dependency, fixes the test. Now, more time passes, but this time, worst thing, production is broken. So let's dig in. You know, here we have this thing that actually fires the book seat, and for obvious reasons, we've mocked that out. And you can see that it takes these three arguments. Well, the maintainer of that transposed the second and third argument for whatever reason, and our test continued to pass. It was a fantasy green test, and as a result, production blew up because the build was green. Now, the person on the left who hates mocking would point out, hey, this wouldn't have happened if we hadn't mocked this thing out, and he's right, too. So he goes into the test and replaces the fake thing with the real thing and gets you back to passing. And I don't think this is what people meant by ping-pong pair programming, but this kind of passive-aggressive back and forth is exactly what you get if people don't know why they're using a particular tool for a given job. Instead, and this is kind of maybe surprising to hear, like a test that never fails is a bad test because it hasn't told you anything. It's just consumed countless cycles of cloud CPU time in your CI server. Instead, you know it's going to fail, or hopefully it'll fail, so think at the time that you're writing it, what should failure mean for this test? And design that into like how you actually write tests. For example, if you're writing a unit test that's all wired up, all those dependencies are real, sure, nothing is mocked. But let's think about like when it fails. And intuitively, you can say, well, it'll fail whenever the subject or its dependencies logic changes. That's great. It encourages you to be mindful, though, of like what I call redundant code coverage, and that is if you have a module that's depended by 35 different things, and you change that module, you don't want to set yourself up for a situation where you have to now go update 36 different tests. So be thinking about that. Now, if we have isolated unit tests where all the things are faked out, 100% mock, so our mockometer readings are beeping loudly or something. But when it fails, we have a clear definition of what failure means. It means that the contract between the subject and its dependencies changed. And so it should encourage us, though, to like be mindful that like we probably want to have another smoke test, some integrated thing that just makes sure that when everything is plugged together, the app basically seems to work. So that's important, too. But what do we do in this case where half the things are real and half the things are fake? It looks good under the prevailing ideology of like, mocking as moderation, but when does it fail? Well, it can fail for like multiple numerous nonsensical reasons, and so it should encourage us to not write tests like this, so please don't do that. And so instead of critiquing how much mocking you see in a code base, critique why people are using mocks at all, like what's the broader strategy here, and I guarantee you'll have more productive discussions. The common thread between all three of these things is that I think that, we all tend to have this sensation that like realism is very important in testing because we want to make sure things are going to work and that they're not going to explode. But that can actually cause problems where we forget that what testing is really about is like setting up clear experimental control to get consistent results that tell us something that we need to know, and that's important too. All right, so let's move on to like the less obvious abuses. And I want to start with talking about mocking out third-party libraries. So say that you depend on AwesomeLib. It's an NPM package, and there's references to it all over your code base. It's got a kind of funky API, though. First, you call it, and then you pass it a config file, so we read that from disk. That returns an instance of the library that we can then call an optimize method on, and we get all these really cool interpreter hints that we can use to speed up our code. Problem with that is that song and dance is kind of weird, and so it's really hard to mock AwesomeLib. And here's like how you might try to go about it. You fake out the file system, and then you fake out AwesomeLib, and then you create an artificial instance to represent creating one. Then you fake out the file system to say, hey, if you pass the right path, I'll give you something to represent the config. And then when we get the config, we'll return that instance. And then when you call optimize on the instance, we'll call back with some hints. That's a lot of setup. And so you'd be right to look at that and get really frustrated with how much mocking logic you have at the top of your tests. And a lot of people complain about that. But the root cause here has nothing to do with the mocking library. The root cause is that was hard to use code, and that like a mocking library's job is to specify interactions you have with public APIs. And so what the mocking library is doing is it's screaming at you that this is a bad design. So instead, we just like force it, and so we like copy paste that setup across all of our tests. JavaScript, we march along very quickly. New major update is announced to AwesomeLib, and we're really excited that maybe they'll fix this for us, but all they did was change the callbacks to promises. And so now we have to go over here and just add then resolve so that these are now promise resolutions, and we have to do it in 18 different places. JavaScript marches on, and nobody uses AwesomeLib anymore. We find out that like the new hotness is MindBlow, and everyone's pressuring us to go and switch as fast as possible. And so now we're just angry because we have all this pain festering throughout our system. What I found is that like if code is hard to mock, and it's something that you own, it's a module that's in your code base, and you can readily change it, that feedback is fantastic because the remedy is improve the code design. But if it's a third-party thing that you don't control, what are you going to do? Like send a pull request and ask them to change their public API just for you? No, it's not going to work out so well. It's an example of useless pain, and how people go about testing is full of useless pain, so be on the lookout, because it's money out the window. So if you care about testing, you need to minimize the amount of drudgery, or else people are going to come to value it less and view it as a waste of time. So instead of mocking out third-party things, I write little wrappers for them instead. An example of this one might be here, just sequestered off to the periphery of my application. This is the only time I'm ever going to require AwesomeLib in my app, and instead I'm going to expose this simple, awesome callback API that I wish that it did, and sweep under the rug all the other complexity that I have to have. Additionally, doing this by habit gives you some like additional mental space to think, hey, maybe we should be caching this file a read. That's kind of silly. Or we could translate the AwesomeLib errors into something that's like more concordant with like how we write error handling for the rest of the application. And you can just do all that there. Now, additionally, all that test setup, that gets a lot simpler, right? Because now we're just faking out something that we understand that's simple to use, and it creates so much extra room in each test to be thinking about, like, what am I actually trying to specify instead of getting distracted in all sorts of mocking-related rabbit holes. And you don't have to worry about writing unit tests of these things for the same reason. You're not going to improve their design. Just trust the framework to work, because otherwise it's just money out the window. Then the next lesser of the obvious things that I see folks do is when they write a lot of code that tangles up logic with delegation. Let's explain. So let's say that you own a fencing studio and you rent out swords, and your boss says, hey, how many swords are we going to have on Tuesday? And so instead of like being like a normal person, you write a function that takes in a date. You call a network request to fetch out all the rentals that are currently outstanding. You get those back, and then you filter those down, first by calculating the duration of that rental and then figuring out when did the rental start so that I can figure out what's going to be due, then plucking the swords out of it. Now, you also have an inventory, the stuff that's not currently being rented, so you call that too. You get the inventory back, you concatenate the two, and then those are the swords that you're going to get back. So you can report success. How might you test this? Well, you start by creating a fake rental object properly that has the right properties on it. You stub that out so that fetch rentals calls back with it when it's invoked. You stub out the inventory as well, maybe with the second sword. And then with a very particular date argument, you call the subject under test, and you assert that like you get the two swords that you expect. And this works. And you'd have some other test cases too, so it's a little complicated. Time passes, though, it's working fine, and somebody on the team points out, hey, we can speed this code path up now because we have a primed synchronous cache that you can call. You can go into the code and you can eliminate one of these network requests, so you just call that instead, outdent this, and now that looks good, the code is faster, but of course, what? It broke the test. So we're frustrated by that. If you look here, yes, sure enough, we are mocking out this other thing for that part of the behavior. It's not going to do what we want. The test is going to break. And somebody on the team might point out, like, oh, well, the test is coupled to the implementation, and this is very bad. This is a common criticism against mocking, but I don't think it's necessarily bad. I think it's a little bit of a naive criticism. Because like we write a test, and then we assume that it's going to save us in 800 different types of change that the system might undergo. But like at most, it can help us from one or two. So when you're writing tests, think about like, this test is going to make me safe for a certain kind of change, maybe, but design that up front. So for example, if you have, you're writing a test of something that doesn't have any dependencies, it's probably a pure function specifying logic. And that means that if the rules to that logic change, the tests need to change. If you're just refactoring from a for loop to a for each or something, you're probably going to be fine. But like, if you're adding a grace period to these rental durations, the rules of the game change, so you have to update all of your code examples. It is coupled to the implementation in that way. So if you have like another test, though, and you're mocking all the dependencies of the subject, what it does is it specifies those relationships, and so when the contracts change, the test needs to change. The previous example, like if the duration adds a grace period to one of its dependencies, that's internal to that. That's at arm's length. We don't have to worry about that. This test should keep passing. But if we literally change what we depend on to do our job, of course that test is going to break, and you need to fix it. Where this really flies off the rails is when people write subjects that have, both the mocking out dependencies and also implement some amount of logic. It gets really painful. So to illustrate, our own example does this, right? We have this current inventory we're calling, this fetch rental service that we're calling, but then we kind of like adjoin onto that this responsibility to like calculate when swords are due. And you can see it right here. It screams off the page. If you know what to look for, I've got network requests here, and then I got all this logic. And it's the same thing in the test. I've got the network requests here, and then all this logic floating around. And what this is, what we'd call it, is like if we were giving a design critique of this module, we'd say that this is mixed levels of abstraction. Because two of the things that we're doing are happening with like business domain objects that speak in our language, like peers throughout the app. But then we're also dealing with all this primitive gunk. We're implementing logic and multiplying primitive values like integers and such. And that's a classic example of a code smell, and the way that you'd remediate that code smell is by spinning off that third thing, so that sword stock now has a single responsibility. Its job is to break up the work into these three other parts and let them do the real heavy lifting. And that thing that we just spun off is now a lot easier to maintain because it just takes in a couple arguments, spits out an outcome. It's a pure function, really easy to test, really easy to maintain. So if a test is specifying pure logic, there's no easier test to write. Inputs and outputs, there's nothing else to deal with. If a test specifies relationships and only relationships, those are completely under your control. They tend to not change unless the contract changes. But if it specifies both, you're going to have really, really long test cases that change for all sorts of different reasons. It's more useless pain. So if you need a sticky note to like put on your team wall or something, I encourage everyone to write functions that either do something or delegate to someone, but never both. All right, the last lesser of the obvious things that I see people do is when they mock dependencies like halfway down the call stack. So what I mean by that, let's take that we have, we're writing a system to handle travel expenses. So we have our invoicing app, and then we're communicating via HTTP to get some JSON back from our expense system. And so we have a method send invoice, which calls build invoice, which calls to filter the approved ones, which groups them by purchase order, and then loads the expenses, and then that breaks out to HTTP to like load them from the expense system. And then all the way back up the chain with these intermediary data models for those actors. So you might ask, hey, I'm writing a test of this send invoice thing. Which layer do I mock? And it's a good question. So my answer depends on what kind of test you're writing. So if you're writing an isolated unit test as you develop it, I would always say mock out the direct dependency, because you're going to get design feedback of what it's like to invoke that thing. And the test data is going to be completely minimal so that the contract between those two things is really clear. If you're trying to get regression safety and just make sure that things work, I would either mock out nothing or say mock out only like external systems so that you're using the system like a real user would. The benefits here are that like your test data is going to be representative of real life. They're probably going to look like HTTP fixtures. And additionally, if it breaks, you know what that means. It doesn't work anymore. But I see a lot of teams reach for the convenience of just mocking at whatever arbitrary depth comes to mind. And this is kind of the worst of both worlds, because when it fails, it doesn't mean anything other than somebody might have changed something and now you have to update this test. Or like the data that you're loading, the fixtures are all kind of coupled to that thing. And so your data could fall out of sync at any moment. And yet this is probably like 80% of the way that I see people mocking out data providers in their JavaScript apps. So to summarize, if you mock out a direct dependency, the failure is meaningful because it means the contract changed. If you mock out an external system, again, it's a meaningful failure. It means your thing is broken. But if you mock out this intermediate layer, it probably just means that you have to go and do the chore of like updating that test now. And it's going to like, your eyes will glaze over when the build fails because you just have to go update stuff. The common thread between all of these is that when we reach for mocks as just a tool of convenience, they undercut our overall test strategy's return on investment, and it tends to make mocks a four-letter word on a lot of teams. And I said that just realizing mock was already a four-letter word, but you get my point. Let's move on to the questionable uses of mocking. First one I see a lot is when people write mocked out tests for existing code bases. Let's say that you work at an Internet of Things doorbell company, and you're a startup, so you got a lot of spaghetti code, but you just got a lot more funding, so you can finally write all those unit tests that you never did. And you've been really ashamed of the fact that you have 0% code coverage in your system, and so you think, well, what's the first test that I could write? Let's write something real simple and integral to like what our system does, that when you ring the door, the ding count goes up. And so we require a doorbell, and then we require the thing that rings the doorbell. We create a new doorbell, we pass it to that subject, and we make sure that the ding count has been incremented. We run this test, and oh, well, we got the stupid error because you got to have a door for a doorbell. No problem. I'm going to import the door, instantiate a door, pass it to the doorbell, run my test. Except for the fact that a door requires a house. It's fine. We're going to import the house, instantiate it, pass it to the door, which passes the doorbell, which is pass to the subject, run the test. And a house requires a paid subscription, network connection to this other service. And you know what? Now you're just upset and frustrated because like the thing about untested code is very often lots of code paths, especially when we're creating values, are only ever invoked in one place. And so this kind of crap can just like accrue. One of the best things about testing is all your code gets like lots of exercise in lots of different contexts, and so you're incentivized to make value objects that are like cheap and easy to construct. So the right thing to do here is like make your value objects easier to construct, but of course what they do instead is they just knock all that stuff out, replace it with a fake doorbell, set a ding count on it, and then get to passing. But this is not the right reaction. And additionally, like if I had to summarize that into like a motto, I'd say like mock out dependencies. Mock out things that have like application logic that do the work, but pass in real values. That type information should be valuable, and it should be easy to construct them. And besides, tests like this aren't going to get you, they're not going to move the needle very much in this person's situation. Instead, what you probably want with an untested system is more safety to aggressively refactor it, in which case I recommend you to increase the distance. So think of ring bell in the context of its application. Maybe there's an HTTP router in front of it. And then we could write a test that runs in a separate process that interrogates that thing just the way a real user would. So we could send a post request to like exercise the behavior that we want to test, assume that maybe writes to a data store somewhere, and then after we've done that, we can run another request and see whether or not it had the impact that we wanted, or we maybe could look directly at the database. And this is going to provide way more safety to like actually start changing and improving the design of that ring bell subject. Now, integrated tests, they are indeed slower, and they fail for more nonsensical reasons, but they do provide more refactor safety. And if you're in this situation, they're going to be a way more bang for your buck from like a code coverage perspective and actually providing some sort of sense that your build means something. The next questionable use that I see people do a lot is enabling highly layered designs by leveraging mocks. You know, something that I've seen over the years is that testing tends to push us to make smaller objects. So instead of like one gigantic horse-sized duck module, we're writing like 100 duck-sized horse modules. So instead of having a gigantic order.js method with like 800 methods all over it, we might have like a bunch of carefully named different responsibilities in our app in separate files and so forth. Now, I can talk all day about like why big modules are bad, but it's not the case that smaller modules are better just because they're smaller. In fact, if you're like, every time you pick up a new feature and you go to implement it, you're just kind of creating these 6 cookie cutter objects over and over and over again, you're not actually like improving the design. That's just large objects with extra steps. Like, you're adding a bunch of indirection, you're adding a bunch of files, you're not really like improving things. So you might ask, hey, what does this like unsolicited design feedback have to do with mocking? Well, I'll tell you, if we were testing all this stuff and we made a change to this like bottom layer, this really heavily depended on module, of course we would have to update that test. But normally, it would also fail all the tests of the things that depend on that thing and would disincentivize from us layering like this. But mocking comes in, and a lot of teams will be like, all right, cool, well, I can just fake out all the layers beneath me. And so that means that I can create these arbitrarily indirect, stacked up applications with the test no longer providing me that feedback. So mocks actually add a blind spot to teams in this situation. And I would caution you, too, that like layering is not the same thing as abstraction. You're not doing domain modeling if all you're doing is adding more and more layers of indirection. So, of course, I love small modules, I love small things. Make small things, but make sure that they're meaningful, that they solve a distinct purpose, that the name means something, and that you're not just like creating a bunch of files for no reason. So what I'd rather see is an application that only has like one controller, but like it knows who to call at the right time. So maybe there is a responsibility to create an order, and then I just use that as like an escape hatch, like a main method for the create order thing, so that it can only focus on what's special about creating orders, and it doesn't get sucked into all this sort of like carrying the water that is necessary for every single feature if you just kind of copy and paste the same stack over and over again. So if you're in this situation and you're finding that like your isolated unit tests aren't providing you with like useful design feedback, they're not providing you value. Don't do it anymore. In fact, maybe question whether or not like your architecture is too repetitive and redundant and could be improved. The last questionable thing I see is folks who rely too heavily on call verification, where a mocking library lets you verify that a call happened. A lot of people get really excited about that. And I'm a big believer, like in general terms, that we come to value whatever it is we measure. And an assertion is a measurement, and so our assertions tend to steer the design of our systems. So let's say that we run a petting zoo, and you were given a copy of test.js on your birthday, so you're really excited to go mock things out. And what you're excited about is like you love petting the pets, but now you can finally assert when that happens. So you pet the sheep 1 time, you pet the llama, you can even say, hey, I pet the sheep 2 times. You don't pet the crocodile, you can assert that too. Sorry, crocodile. We could write a test for this, right? Like when we pass to this like function a kid and a sheep, it'll return true, as well as for the llama and false for the crocodile. We invoke that subject with those 3 animals, and then we verify that the sheep and the llama get pet, but that the crocodile didn't. Now, to implement something that passes this test, we import those 2 things, and then we pass in the kid and the animals for each of those animals. If the kid likes the animal, it pets the animal. Now we got to a passing test. Great. There's one problem, though, which is like kids have dirty hands, and the pet function doesn't say how dirty, and we got to clean the animals at this petting zoo. And so you just have to guess, and so you set up a cron job to hose down the llamas every night at 10 p.m., which is a tremendous waste of water. So we want to do better. What happened here is actually an example of like where tools can mislead us, because tools are awesome because they save us time by reducing the necessary thoughts and actions we need to take in order to get a job done. But if we're not careful, sometimes our tools can actually eliminate useful thoughts. And that happened in this case. Now, just because you're able to verify calls with your mocking library, you have to realized that it might encourage you to write more impure functions. And impure functions, those that have side effects, are harder to maintain than pure functions, those that return values. Because nowhere when I was writing this code did I think to ask, hey, what value should pet return? Because I had a convenient way to assert that it was just called. And if I had to think about that, I'd say, well, the pet function should probably take an animal and then return a dirtier version of that animal, I guess. So let's pretend we did that. And here we're going to stub out that when we pet the sheep, we get a dirty sheep. When we pet the llama, we get a dirty llama. Now we care about this result, and we're going to assert that we get a dirty sheep, a dirty llama, and a clean crocodile, so other parts of our system know which animals to clean at the end of the day. We update the implementation like this. First, we're going to take away this for each. Whenever you see a for each anywhere, any kind of loop, you know that your application is just screaming side effect because it doesn't return anything. So we're going to change that to a map instead and trade one array for another and return the value of that pet call. And of course, if the kid doesn't like the animal, we'll just return the animal as it was, and this passes the test. So now we know to watch these first two, and we can spare the third. There's just one last thing here, is if you actually run this test, you're going to get a really big warning up at the top, because it's going to tell you that you stubbed and verified exactly the same call, and that was probably redundant. And what does that mean? Well, if you look at this test, we're now verifying explicitly every single thing that happens, but we no longer need to be, because we're also stubbing these things and asserting on the values that come back. And so it's almost provably redundant. And that means we can just remove that stuff, simplify the test. And so in general, after years and years and years of writing and using mocking libraries, I've come to view verification as just the assertion of last resort. Only if it really makes sense for the thing I'm calling to not return a value, or if it's out of my hands, out of my control, do I actually write assertions using verification. The common thread between all three of these things is that we forget that mocking libraries were invented to provide rich design feedback to improve the design, the simplicity of our systems. And if we ignore that, then we're just introducing yet more useless pain. All right, so that was a lot of things to not do. The one thing that I really like, let's talk about that. So I was really inspired by this book called Growing Object-Oriented Software Guided by Tests by Steve Freeman and Nat Price years ago. And I've iterated on it enough that Nat has kindly asked me to call what I do something else. So I call it discovery testing. We're going to do a quick demo. So suppose that you write conference talks, but it takes too long. There's just too much emoji and fiddling and stuff. So you decide, let's automate it. And so you take something that loads up all your notes, you run it through a sentiment analyzer to find what emoji should match up, and then you generate a keynote file. If we start a test like this and we're practicing discovery testing, I always start with the setup of the very top layer, and then I ask myself, what's the code that I wish I had? Because I'm lazy, and I'm also relatively incompetent, and when I'm looking at a blank code listing, I just panic and assume that I'm too dumb to figure it out. But if I could just say, hey, I wish I had something that loads notes, and something that pairs those notes up with emoji to create slides, and then finally something to create the keynote file for me, that I can understand. And then, I load up my subject, and I can start thinking about the test. Well, of course, the test should be that it creates the keynote from the notes. I run this test, and it fails, because I'm talking about code that doesn't exist. So it says, hey, this module isn't real. So I just touch it, and then I run it again. And then this other one, the second pair emoji isn't real, touch it, run it again. And then create file isn't real, et cetera, et cetera. And I got that to passing. And what I love about that is that it gives me small incremental forward progress throughout the day. Even if all I accomplished just then was the plumbing of my application, it feels like paint by number. And programming is an area of just professional life where I really wish that things could, we'd get more feedback through the day, hey, good job, bad job. And sometimes people go days, weeks, months without any real feedback that they're on the right path. So testing this way soothes my anxiety. And now, I've broken this work up into these three responsibilities here. So I can start writing the actual tests now. I assume I'm going to need something to represent notes, so I create a note domain module. And when I stub, for a given search string, I should call back with those notes. I assume I'm going to need a slide value as well, and so when I call this pair emoji thing with the notes, it just should return these slides synchronously. I call my subject with that search string and the given path that I want to write it to the file to, and then I verify that create file was called with those slides at that path. Run my test again. And here's the message I've been working towards all this time, right? I expected this to be called with these slides at that path. I can make this test pass by importing the three still empty modules. We're going to fake that out at runtime. Passing the topic to load notes, get the callback, create the slides, and then create the file with those slides in that given path. I run this test, and now it passes. Now, you'd be right to ask, like, that was a lot of words and minutes for 5 lines of code. Like, how is this actually a productive use of your time? And the answer is I've actually done a lot of work here just by thinking through all these things. I just agreed to, hey, this is our public API of these 2 strings. I know that when I pass a topic into load notes, I get notes back. I know paraemoji trades notes for slides. And I know that we pass slides and path to some other responsibility. The subject at this point, the entry point, is done. I'm not kidding when I say I often never look at that top level again. I've successfully broken it up into 3 problems. The work is broken down into 3 things that we know the contract, so you don't have to worry about the fiddly bits getting all tangled together at some point. They have different jobs that we know in advance. And we've already proven out the contract between those things, so we know what to call them with because there's already something calling them. And that's great. So additionally, we sussed out a couple of value types that we want to be passing through these methods. We have some notes and some slides. And the next step is, it's a tree, right? It's just recursion. So we ask, okay, so what do we want load notes to do? Well, it's got to read from some note file, parse our outline, and then flatten those points so that we're having a linear presentation. And the first is I/O, and the second and third are just pure functions. And writing tests for pure functions, like we talked about, is really easy, so we want to maximize those. The paraemoji thing, maybe we tokenize those notes, and then we run that off to a sentiment analyzer, and then we convert them to slides. And the first thing's a pure function. The second thing is, again, probably going to be a wrapper, because I don't want to figure out how to do sentiment analysis. And then another pure function. This last bit, we want to build some kind of layout from those slides, like text goes on top, emoji down here, or whatever. Then we need to generate AppleScript commands, so we can actually know, have a big array of everything we need to automate with Keynote. And then finally, something who's responsible for rifling through all of those commands and generating the file for us. The first and second are, again, pure functions, real easy. And the last one would just shell out to this thing called OSA script that's going to open up AppleScript and automate Keynote. What I love about this process is it gives me reliable incremental progress throughout my day. What shakes out the other end is a bunch of single responsibility units with intention-revealing names. The organization of all these small things is actually discoverable. If I create a new directory every time I recurse, well, if you're reading my code, you only have to dive as deep as you seem to be interested to answer the question you're looking for. It separates out all of the values from the logic by default, so it doesn't tangle those up. And I spend most of my time writing really easy, synchronous pure functions, which are the easiest kind of code to maintain. That's all I got. So I thank you for being patient. I really am grateful that you showed up at a talk late in the day. Like I mentioned, TestDouble, we're a consultancy. If your team is looking for experienced developers, maybe you're only thinking about hiring, but you might be open to talking to us instead about how we might be able to help out and integrate with your team. I'd love to meet you. Check out our website. We're also hiring, so if you'd like to work remotely, you kind of share our passion for improving how the world writes software, and you want to share your experience with others, check out our join page. Video of this talk, I've got a previous one from Assert.js in February. I've buffered it up, so it's going to be tweeting the video link momentarily to my Twitter account, Searls. Would also love to see your feedback through our website forum. Also, I've got brand new TestDouble stickers, our new alternate logo. I'm going to be here all week, and if you ask for a sticker, I'd be happy to give you one. There's just one last thing I want to share before we go, which is my wonderful wife, Becky, down in front. She put in a lot of work this morning, took a lift out to the store and came back. She just for your all's benefit, I'm not the generous type, but she is. But I am the head of marketing for TestDouble, so I saw an opportunity. And she purchased every last bug spray at the Target nearby. So thank you, Becky. And then I affixed branded stickers onto each of them. So here's the deal, because there's not enough of these for everybody. If you come and meet us at dinner and you talk a little bit and you say just enough to demonstrate that you actually showed up to a 5:45 p.m. talk, we will happily give you a bug spray until we run out of them. That's our little gift to you. Thank you for your patience. I had a really good time speaking here today.